Il est temps, on y va?
Good afternoon, everyone. It's a pleasure to be here. First, I would like to thank the organizer for having me today. My name is Jean-Joseph Achizian. I'm responsible for the Analytics and AI department at the NSSO. And today I will talk about a project we've been working on for the last few months, PureID. So it's an innovative approach to entity resolution. Maybe I should start by saying who we are. So the NSSO is the National Social Security Office in Belgium. We're located in Brussels, South Train Station. We were founded in 1944. And we're part of a group of 13 other public institutions for the social security in Belgium. I invite you to go on our website to learn more about us. And maybe I should also say something about what we do. The goal of NSSO is to collect contribution and data related to social security. So, for example, we collect contribution from the employees and employers. We collect data about the wages, about the working hours, so to make sure that our social security system functions correctly as well. We're also offering social security to people abroad and seafarers, and to fund also the social marble. One of the tasks that we have is to inform and support people, employees and employers. For example, if you are a student and you need to work in Belgium, there are rules and we have to make sure we can help them work if they search for work. Another things that we do, of course, is to make sure that our social security is conform and there is no frauds within our social security system. And we have here special departments for inspection that are going on the field and are checking if employers are doing things legally. They are also checking for abuse, something that also happened today. Maybe it's well known for you, social dumping, where people are coming to our country to work, but are getting low wages and sometimes no health insurance. But here today, where it all started, we began this project because, like a lot of companies, of institutions, we have a lot of databases. And something that people have to deal every day. And sometimes you want to match those databases together. It's not always easy to do this. Why? Because you can have different business keys between the different databases, name, addresses, and format. Sometimes we've seen that. I will show an example. Format can be different, and if you try to merge those data together, it won't be good. Why this matters? Of course, if you want to do accurate entity resolution, for us it's very important so we can do correct identification. We also want to make sure we can detect fraud. We want to be compliant, but also it's very important for your data quality. If you try to do an analysis with your data and the data is not good, you won't get good results. And these examples here on the right, very easy to understand. If you try to do an analysis on the United States, but then in your data it's United States, USA, and US, you won't get the good analysis that you want. If I go more in details, here, imagine you have 4 databases and you put everything together. This is what it could look like. If you have business keys, like VAT, of a key like VAT, number, it could be that it's not everywhere in all your databases. It could be also that they are found, it's wrong or it's written. People have made a mistake with typing the VAT number. Then if you look at the name, it could be that the language is not the same between your databases. We have something in French, and I think the second here is in Hebrew. It could also be that the number of the street, for example, is not the same. Here we have different ways to write it. Sometimes it's 3 digits, sometimes it's 5 digits, and it's difficult. Sometimes you see, well, also that the street number is in the street name, street address, or in the name itself. Here we're working with a different country as well, it's France. So the zip code is special, it's different from what we're used to, and there are different ways to write it. And then I go further on with the cities, for example. You could write it short or longer, different ways to do it. And so that's a problem we want to tackle at the NSSO today, because those things we see every day. But maybe I should come back quickly to say what is entity resolution. It's deciding whether two records refer to the same real-world entity. So it's a very simple example. We have two people here with a name and an address. Are they the same person? And entity resolution helps do that. In this case, there's a good chance that those two records are the same. There are traditional techniques that are well known, well used, fuzzy matching. And what it does here, it just makes sure you do entity resolution by doing string matching. So you will look at string per string, are they similar, yes or no. And here I take a specific use case, which is in PostgreSQL for the people using relational databases, and it's trigram, for example, that's available in. What does it do? It would look at similarity in characters. You can go character per character and look if there's similarity. You could do that with word as well. So you would look at, okay, each word in my sentence, are they the same, yes or no? You could also use a bit further what they call here trigram. So you would take 3 characters per 3 characters. Okay, different ways, many ways to do that. And what you're trying to get is, again, a similarity score. So you have the picture on the right side. So you have an address. It's an address that you're looking for. And then you look at the second records, and you see here the unit 4 is misplaced. You still have a good similarity score from 0.92. But then if you go further down, if you take the 4th one, then street is not fully spelled. You have unit 5 instead of unit 4. And then the zip code, you're missing a number. So here's the matching, not really good. The score is not really good. So what is PureID and why I'm here today? It's just to show you how we try to resolve this problem, but with AI. PureID is an AI-based system that will analyze 2 records and more to make sure that to make sure we can get the same real-world entity if needed. You have to think about it like Google. When you go on Google and you're looking for a picture, you're asking for a cat, and what you will click on the button here, which is like a camera, and what will Google do? It would find all the similarities cat picture that they have in their database. And that's what we will do today. So very simple technique, or it looks very simple here at Google, and we want to show you how we do it. It's a combination, so PureID is a combination of different techniques. The first one we use is large language model. You all know generative AI is becoming big. Today we can do a lot of things with text, and we're using large language model as the basis for PureID. What we do, LLMs, what they're good at, they can do embeddings that will convert your text in numbers that represent the meaning. So if you have the address here, for example, Propol Energy France, Cours Michelet 24 Paris, you will get a numerical representation of this as well. Why is this so powerful and so interesting for entity resolution? It would capture the meaning of the word. So for example, an LLM will know that Paris is a city. It would also know that Cours Michelet 24 is an address, and so on. It's really good to noise as well. So if you're making spelling mistakes, wrong name, wrong addresses, or false mistakes, sorry, in the address, then it will be able to capture it to a certain extent. It doesn't matter which order you take. Of course, if you have all the an address, and you start with the city, and at the end, the name is not very important for the LLM as well. It's very good, like I say, for different languages. We all know this. If you have something in French, in Japan, or something else, they can deal with them. And of course, they can also be good for abbreviations, which is very good as well. So it allows us to compare messy data, multilingual records based on their meaning, and not just spelling, like it could be with other techniques. So that's step one. So to give you a bit more details, we're working in Belgium, and you all know we have 3 languages here in Belgium. 2 main languages are Dutch and French, and for LLM, it's very easy to know that Stationsstraat is the same as Rue de la Gare, for example. Very, very helpful for us. I'll say about it as well, language. It can understand different scripts, Latin, Cyrillic, Hebrew, Japanese. Here what we see is someone's name written in 2 different languages, but for the LLM, it's the same person. And other things that I already mentioned, but maybe writing styles is important. If you have John 3, it's the same as John the 3rd. So quite helpful. The second thing that we do with PureID is to look at nearest neighbor. What is this? Here we will find the most similar entities of a way with approximate nearest neighbor. So what we would do, instead we will map every record that we have in a multi-dimensional space. Is represented in a 2D space, and we will look at the similarities between them. What's interesting here is it's a bit like Google. Instead of looking for all the similarities in your database, you will look at the most maybe on 20 records that are very close to them. So it's very fast and scalable, because it's okay to look at all the records in a database if the database is small. But what if you have millions and millions of records? You cannot do that. So that's why approximate nearest neighbor is very interesting for us. So to give you an example, very simple, you have here 6 different entities. Propol Energies, France, you have Propol France, number 3, Propol Belgium, and you will get a score. And for example, bracket 1, bracket 2 are very similar to each other, because you have Paris, you have 24 Cours Michelet 24, and you have Propol SA and Propol Energy France. And then you can go on, and you will get, like you do for fuzzy matching sums, you will get a score, okay? And you see here, number 6, Propol Shop, Belgium. We don't find any similar records. Next, of course, is we use the graph technology here, because what we saw is how to match 2 records together, but if you have a lot of duplicates in your data and you want to do entity resolution, you want to make sure you can group them differently. So it's not only a match one-on-one. For example, in what I just saw earlier, we have a cluster of 3 entities that should be the same, what we call PureID number 1. Here we can see that those 3 together, they were closed in a space that we drew, but then they should form also a cluster. And then you have, for example, a second cluster here for Propol Belgium, and we see they're not the same, because here they're in Brussels and the other one is in Paris, and then the third one, it should be alone. So graph technology is here to help us to make sure we can make clusters of our data. All those 3 components are here to make PureID what I showed today. So it's not only one technique that we can apply, it's a combination of techniques, LLM, nearest neighbor, and graph, that make it possible to make a good entity resolution in this case. Why is it important for us? It's very accurate. We've done some tests and with other techniques, traditional techniques, and we've seen a better accuracy in what we do. So it captures very complex variation in names and addresses, and other entities, and that's why its accuracy is higher. It's very scalable. It's very important. You can realize and you can do entity resolution on small databases with the techniques, but if you have millions and millions of records, it should be scalable and fast. It's robust to variation. I will explain it earlier. So if you have different languages, it can cope with it. We're adding graph to make sure we can cluster technologies together. We do semantic understanding, like I said. So we go beyond entity represented. We go beyond simple string matching here. We try to have context about the words that are given to PureID. It's very flexible because it's something that's very important. If you are working with one or two databases and later you want to cross with another database, it should not ask you a lot of time to do this again. It's very flexible, so you add it, you run it again, and you have your results. The other point via also, what's very important here is because having memory today costs a lot of money, and if you can remove duplicates, and I will show you an example after, you could save a lot of memory and money as well. So it's not, it's quite important for us as well. And also it allows to work faster, also to work better, but to work faster. And what also, I didn't add here, but everything that we do with PureID is on-premise, so we're not running anything on the cloud. We're doing on our servers at NSSO, and it helps to also for confidentiality. If we're working with data that is a bit sensitive, we can do it without any problem. I still want to add a disclaimer here, of course. Despite using advanced technique for entity resolution, PureID of other techniques cannot guarantee 100% accuracy. And you will always get false positives, incorrectly linked entities, or false negatives, mismatches. And now you should always know that such solutions are here as a supporting tool rather than absolute decision maker. And that's very important because the consequences can be big if you mismatch someone. Also, we can improve with the time of a better solution, but it will remain 100% not an attainable goal today. I want to give you here an example how we applied it. So we have databases with a lot of addresses, approximately 30 million records today, and we applied PureID, and we went down to 23 million records, so quite a drop from 7 duplicates in our database. How we do it, so here's an example. What we do is we have the data that we collect, we have an initial load, we do the address parsing, so we will get different data together in different columns, and we have trained our own LLM here to do this, so it's a bit, it's not definitely related with entity resolution, but it helps us to do better address parsing. And then we do an address validation. We have a vector database here, and we will look also with best address and open address to make sure that the address can be validated. And then we will do what I say about the address matching with PureID, and we have a clean database for addresses. If new sources are coming, which is the case for us, we will do a delta load, and then the rest falls until you get, again, good addresses and a clean database. But we didn't stop really here. We went beyond this because it's not only about finding duplicates, it's also, for example, finding similarities and so on. So what we did is we built our own libraries to do this. And here, depending on your task that you want to do, you can use core components like a sentence builder, art matcher, NNN matcher, entity cluster, and so on. And you build a pipeline to do this. What's for us important here is to make sure we can respond to the needs of the NSSO if necessary and quickly. For example, I talked about duplicates. From our use case, we went down from 28 millions to 23 millions. Now we're starting from a clean database. Yeah, maybe you don't want duplicates anymore. So what you could do is apply similarity search techniques. What I mean by that is, okay, you have a clean database with addresses, come something new to add, a new address, and you want to make sure before you ingest it in your database, you can say, does this entity exist already in my database? And in this case, you would look at it with similarity search, with what we built with PureID, and you will get a probability, yes or no, or probability from 0.5, decide. And then you decide this record should be added, or this record should not be added. So it's another way to apply it. In this case, if you want to apply it quickly, we just use our new libraries that we just built, and we just choose 2 of the components. So we won't try to do duplicate detection, but we will try to do similarity search, and it's just sentence builder and then a matcher, and then you get your similarity search with your score. What's for us important as well is that we can deploy it and use it very efficiently. So like I said, we built a library to do that. Here, in a simple example, you can see we import in Python for the ones who know Python. We import a library, DupliFinder, and we want to do duplicate detection. We have a data frame, and then we just call the function like we do for the rest with Python. So you give your data. You say, I want to do a match on soft columns and hard columns, for example, name or address for the soft columns, and you want to be strict on hard columns, like VAT. And then you can go on and say, okay, I want to do a more light. So that means I want you to go fast, but not to go too precise for this case, or you want to do large, and you get a better quality as well, and then you run it. And here what you see is an output is to say, okay, records 1 and records 2 are the same. We gave the same ID for Acme Corporation, and we see totally different corporation as a different ID. But what you can also do is just to make sure you can get a golden record, because what you do once you have a cluster, if you have a cluster from 5 entities, which one is your golden record? Which one should you choose? And here you can also use LLMs to do that, to help you give a score and say, we think that these records should be the golden record. And in this case, Acme Corporation comes as golden record instead of Acme Corporation. And that's it for me today. But first, I would like to thank Christoph Zutermann. Without him, it was not possible to do this today. And also, I would like to thank my other colleagues at the NSSO. I also want to thank RZ because we're trying to innovate a lot, and you have to have a management that helps you do that. So I want to thank them as well, and I want to thank you for your attention. Thank you very much.